Okay, so this is a problem for homework 2, number 11, also known as 8.1.19-T. Okay, so here what we have is they give us some information about a distribution, and we have to answer all of these questions. So we're going to walk through this. Don't worry, I know it seems like a lot, but it's actually a lot easier than you think. So it says, suppose the lengths of the pregnancies of a certain animal are approximately normally distributed with a mean of mu equals 249 days and standard deviation sigma equals 22 days. We need to complete parts A through F here. So the first thing I would do to find this probability that a randomly selected pregnancy lasts less than 241 days, and again, your numbers are going to be a little bit different, but you'll do this problem the exact same way that I'm doing, is I'm going to go to question help and I'm going to open StatCrunch. StatCrunch is going to make this so much easier for you. So what we're going to do here is we're going to go to Stat, and we're going to go to Calculators, and we're going to pull up our normal calculator. Okay, now if we look here, I'm just going to minimize this for a moment. If we look here, they're giving us the mean is 249 and the standard deviation is 22. So let me open this back up. We're going to put our mean is 249. That's over here is our mean, and our standard deviation is 22. Now it's not going to change how this graph kind of looks, but you're going to see how it changes your x and y axis here. Now they wanted the probability that a pregnancy lasts less than 241 days. So what we're going to do here, you see you have x is less than. You could also change this to greater than depending on which one you're doing, okay? Also with this normal calculator, you can do between if we needed to. You can also do the 68, 95, 99.7 ticks if you wanted to as well. It puts those in there. Okay, but we don't need those right now. So we'll do this to the standard here. And we want it, again, to be less than 241 days. So we're going to do 241 days and click compute. And here we have our probability, 0.3580. And I believe they wanted us to round to 4 decimal places. Yes. So because that 6 is next to the 0 to the right, we are going to round the 0 to a 1. So we're going to put in 0.3581. I'm going to just minimize this for a moment. And you can see that's how they got their answer here. Now we're going to interpret the probability. Now what they're saying here is if we actually have 100 pregnant individuals of this animal, whatever it is, how many pregnancies would we expect to last here? And because we're doing less than 241 days, pick the one that says less than. But the way they're getting this 36 is they're taking the 0.3581 and they're multiplying by 100. Now you can't have, if you actually do this, you're going to get 35.81. But we can't have 35.81 animals, right? You can't have part of an animal. That's why we're rounding to 36 here. Okay, and again, so we're approximating, we have to round to a whole number if we're dealing with an individual. Okay, so that's why we're doing, if 100 pregnant individuals were selected independently from this population, we would expect 36, again 0.3581 times 100, to last less than 241 days. Okay, now we're getting into the idea of a sampling distribution. Now, a sampling distribution is when we're taking a certain number of pregnancies here. Now, with a sampling distribution, what happens is that you still have the same mean. So the mean of a sampling distribution is equal to the mean of the population. But what happens with sigma, what happens to your standard deviation, is that it is changed a bit. And what we do is we take the original standard deviation and we divide by the square root of the sample size. Okay, so let's talk about how they got, of course, the 249 is going to be the same. Those are going to always be the same, right? But we're sampling 17 pregnancies here. So that means we're going to take this standard deviation of 22 and we're going to divide by the square root of 17. So let me just open my calculator here so you can see how this works. I usually just use the Google calculator. So I'm going to take 22 and I'm going to divide by the square root of 17. And you can see we're getting 5.3357, and if we look over here, they're rounding to 4 decimal places, so they called it 5.3358. And again, the reason for that is because next to this 7 is an 8. Any number bigger than 5, we're going to round up. That's why that 7 is going up. Okay? Now, in this case, they're saying, what is the probability that a random sample of 17 pregnancies has a mean gestation period of 241 days or less? So what we're going to do here is we're going to go and change our random distribution that we did before, our normal distribution. So I'm going to go over here, and I'm still going to keep my mean at 249, but remember, we now changed that to 5.3358 for our standard deviation. So 5.3358. And again, they still want it, I believe, the 241 days. Sorry to kind of make you dizzy here. They still want the 241 days. Notice they have now the answer is 0.0669. Let's check us here. And I'm getting 0.00668. But again, we're rounding that to a 9 because there's a 9 next to it. So again, all you had to do is change your standard deviation because you're dealing with the sampling distribution. Okay, now again, we're going to do the same thing we did in the first part here. They're saying if 100 pregnancies were, obtained from this population, we would have, again, 7, because I'm going to go ahead and multiply 0.0669 times 100, but that would get me 6.69, and I can't have 0.69 of an individual. Excuse me for sneezing. So we were going to round that up to 7. So we have 7 would have a sample mean of 241 days or less, because that's what we found with our distribution here, is less than 241 days. Okay, moving on to part D. What is the probability that a random sample of 40 pregnancies has a mean gestation period of 241 days or less? So you're going to go through the same thing here where we have to go ahead and talk about the sampling distribution. But now they're doing 40 pregnancies, right? So we're going to go back to our calculator, and I'm going to take 22, and we're going to divide by the square root of 40. Okay, now that's going to get us a new standard deviation of 3.4785 if I round to 4 decimal places. So 3.4785. So let's go over here, and we're going to change this. 3.4785. And here we go. And you can see we're getting a probability of 0.0107. Now next to it's a 2, so I'm not going to round that up. Let's see if that's what they got. Oh, they did, 0.0107. Now again, with this next piece, I'm going to go ahead and talk about multiplying this number times 100. So if I do that, I'm going to get 1.07, but again, I can't have 0.07 of an individual, so we're going to round that down to 1. And again, 241 days or less is the key here. Okay. Part E, what might you conclude if a random sample of 40 pregnancies resulted in a mean gestation period of 241 days or less? So they're saying, what does this actually mean if you have the, the probability is 0.0107? Well, anything that is less than 5%, so less than 0.05, is considered unusual. So because we have 0.01, right, this is considered unusual because it's less than 0.05. So the sample likely came from a population whose mean gestation period is less than 249 days. Okay. Then also it says, what is the probability a random sample of size 20 will have a mean gestation period within 8 days of the mean? So now this is a little bit tougher. You want within 8 days of the mean. So let's talk about how we're going to do that. Now they're changing their sample size again. They're changing it to 20. So we have to go back to our calculator, and we're going to do 22 divided by the square root of 20. And we're going to press equals. Okay, and we're getting 4.9193. Again, we're going to keep that 3 the same now because there's a 4 next to it. So 4.9193. So I'm going to go over here and do 4.4193. And they want to say, they want the probability that we're, again, within 8 days. Now that means plus or minus 4 days from the mean, right? So I would subtract 4 days from the mean and add 4 days to the mean to get which probability I want. So we're going to use this between function. So I'm going to press between, and we're going to go 4 on either side of the mean. So if I take 249 and I subtract 4, I'm going to get 245. And if I add 4, I'm going to get 253. Let's hope I did that correctly. 253. And click compute. And we're getting a probability of 0.6345, but there's a 9 next to it, so we round to a 6. So 0.6346. Ooh, and they're getting 0.8961. So let me see here. Did they mean that they want it within 8 days? Oh, you know what? I'm a little bit off here. Within 8 days of the mean, we're going to go plus and minus 8 days. See, I made a mistake here. So I was thinking an 8-day window, but we actually want plus or minus 8 days. So I'm going to make this 241. And then if I add 8 to this, we're going to get 257. So let's click compute and see if we get the right answer. Did I do that correctly? So let's see here. So subtract 8 days, I get 241. Add 8 days, I'm getting 257, and I'm still not getting the right answer here. So let's see here. They're getting 0.8961. Did I get the correct sample standard deviation? So let's see here. Let's see. Let me check all of my work here. Even I make mistakes, so we have to make sure that we do this. Divided by the square root of 20, 4.9193. Oh, here we go. 9193. Let's check and see if, oh, I get the right answer now. It was all an error in how I took my number from my calculator. And it looks like we are getting the correct answer. So these are things that you want to check as you go through if you're not getting the correct answer. I often find that one of my biggest mistakes is that I don't copy correctly, especially when I'm doing these videos. I have to write things down as I go from one calculator to another because I tend not to get there correctly. So 0.8961, let's see if that's what they got. 0.8961, and that is correct. So again, things to check. Did I actually plug things into the calculator correctly? Did I take those numbers from the calculator to the other calculator correctly? It's a good thing to do. So I know this is a long problem, but let me know if you have any more questions on this. It is a little bit difficult sometimes to understand something when they're this long, but I'm happy to help. Tell me what you need.